Hello students, welcome back to the math class, and again we are going to continue with our chapter Be My Multiple, I'll Be a Factor. Okay, before proceeding ahead, let's discuss about what we have learned till now. We have learned about the cat and the mouse, the dice game and the meow game, the meow factor. We were discussing about the common multiples. Now we will carry forward with the same chapter and we will learn some other concepts about the multiples and the factors. So let's move forward. So let's check some common multiples for 4, 5 and 6. As given in your book, 3 circles are intersecting each other. One is for 4, 5 and 6. So the numbers those lie in this part of the intersection are actually common, because this is the common part of the intersecting circles. So let's check. We'll put all the numbers those are common to 4, 5 and 6 here. Okay. So what are there in the 4 table? 4, 8, 12, 16, 20, 24 and so on up to 40. Here 6, 12, 18, okay, up to 60. Here 5, 10, 15 and so on up to 50. Can you find any number which lies in 4, 6 and 5? No. We don't have any number like this, as we are leaving some numbers over here. In this dotted form, we have actually 5 8s are 40. Here 6 10s are 60. Here 4 10s are 40. So I can write 40 over here, the intersecting circle between 4 and 5. It is a common multiple of 4 and 5, because 40 is completely divisible by 4 and 5. Let's check with 5 and 6. We have left some number over here. Here 6 5s are 30 and 5 6s are 30. So 30 is a common multiple of 6 and 5. So I can write it over here. Okay. So in this way we can find out some multiples those are common to 4 and 6. We have many common multiples. See, 12, it's a common multiple of 4 and 6, such as 24, it is also a common multiple of 4 and 6. So we come to know that the numbers which are divisible by multiple numbers, those numbers are called the common multiple. And the numbers we know in the division system which divide another number are called the divisors. That means we can say that the divisors are nothing but the factors, and the dividends which are divisible by the divisor are called the multiples. Just like 30 is completely divisible by 6, so 30 is the multiple which is the dividend in this case. Again I am saying 30 is dividend in this case, and it is completely divisible by 6, which is the divisor in this case. So 30 is the multiple of 6 and 6 is the factor of 30. Same way I can divide 30 by 5. So 5 is also a factor of 30. So 6 and 5 are factors of 30, and 30 is a common multiple of 5 and 6. Got it? Let's do a puzzle of tamarind seeds. Okay, have you seen the tamarind seeds? You might be seeing the tamarind seeds. If you don't know, it is nothing but which we call in Hindi imli, as written in your book. So let's take out some seeds and play with it. What it says, we have some seeds and we are making some groups. Okay, we have some seeds and we are making some groups. And after making the groups, still one seed is left. Still one seed is left. Why so? Why is it so? Because see, if I make a group of suppose 2, 3, 4 and I say that one seed is still left, that means in division system, the remainder is 1. The remainder is 1. That means when those number of seeds are divisible by 2, the remainder should be 0. But at it is not divisible by 2, the remainder is 1. That means one seed is still left to be grouped. So if I group in this way, I have one seed left. So I have to go for a common multiple of 2, 3 and 4. Suppose 2, 3, 4, the common multiple is your 12. Common multiple is 12 because 12 lies in the tables of 2, 3 and 4. So if I take 13 seeds, then I will have one seed left to be grouped, because 2 will divide 12 and give me remainder 0. 3 will divide 12 and give me remainder 0. 4 will divide 12 and give me remainder 0. But if I get 13, so I will have remainder 1 in each case. So I can take 13 seeds to be grouped for 2, 3 and 4. Now you solve the puzzle given in your book, and I hope you can very well solve that puzzle. So if we take some more tamarind seeds, for example 12, so how can we make a rectangle out of that? Let's check. 12, okay, is 2 6 are 12, again 3 4 are 12. So we can make rectangles of 2 and 6, 3 and 4 as well as 1 and 12. So why is it so? 1 12s are 12, 2 6 are 12, 3 4s are 12. So 12 is common multiple of 1, 12, 6, 2, 3 and 4. These are the factors. So what are the factors? 1, 2, 3, 4, 6 and 12. These all are the factors of 12, and 12 is called the common multiple of all these numbers. Now as given in your book coloring the grid, you can find a rectangle in grey color that has width of 2 boxes. So what is the length? Can you count? Yes, it's 10 boxes, isn't it? So this rectangle is of 20 boxes. So we can arrange those 20 boxes with a width of 2 and a length of 10 boxes. So 10 and 2 both are the factors of 20, and 20 is the common multiple for 2 and 10. You can draw as many as rectangles by taking different numbers like 30, 40, 25 and so on. So the other story, that is the story of the bangles. There are 18 bangles on the rod. Meena is trying to group them. She can put them in group of 2, 3, 6, 9 and 18 without any bangles being left. Why so? 18. See, I say that these bangles can be arranged in the group of 2, 3, 6, 9, 18. Why so? Because 18 is completely divisible by all these numbers. So when I divide 18 with 2, 3, 6, 9, 18, they give me remainder 0. So no bangles will be left. If there are suppose 19 bangles, so there will be one bangle left to be grouped. So in that case 19 is not a multiple of these numbers, whereas 18 is the multiple of 2, 3, 6, 9, 18, and as all these numbers including 1, they divide 18 completely. So these numbers are called the factors of 18, in which 1 and 18 we can see that every number is a factor of itself, and every number has a factor that is 1. So we can say that any number, it has two factors, 1 and the number itself. Every number has two factors, that is 1 and the number itself. And the next page you can find the multiplication chart, in which you can find that some numbers are colored in green. Which is that number? That is number 12. As we have discussed previously, we know that when we go on finding out multiples or common multiples, we can find out them through the tables. As we have found out the common multiples of 2, 3 and 4, in this way we can find out the common multiples of any number by going through the multiplication chart. In this chart given, you can find that 12 lies in all the tables of 1, 2, 3, 4, 6 and 12 itself. So, 12 is a common multiple for 1, 2, 3, 4, 6 and 12, and all these numbers 1, 2, 3, 4, 6 and 12 are the factors of 12. That is why 12 can be represented as 1 into 12, 2 into 6, 4 into 3 and so on. So, these are the factors of 12. So, in this way we can make the rectangle out of it with a width of 1, length of 12, width of 2, length of 6, width of 4 and length of 3 and so on. We can alter them as well, like 12 into 1, 6 into 2, 3 into 4. Got it? So, students, let us talk about the factor tree now. And factor tree is very important for you because multiples and factors are important in all the concepts of mathematics, and you will be dealing with all these things throughout your mathematics career. Okay? So, what is a factor tree? It is a tree having branches. The tree having branches. Which tree? Tree of a number. For example, suppose 10. Let us circle it. So, which all are the numbers which have 10 in its table? First of all, the smallest number, that is 1, tens are. Again, another branch, let us go for 2, 2 fives are. 10, let us go for 10, 10 ones are. So, 10, 2, 5 and 1, these are the factors of 10. So, let us build another factor tree. Let us go for a number 12. So, 2 6 are 12. Let us take a branch of 6. 2 3s are 6. So, now 3, 2, 6, 12, and as I already told you, 1 is a factor of all the numbers. So, 1, 2, 3, 6, 12, these are the factors of 12, and 12 is the multiple of these numbers. But is it true? Whether we are missing something? Whether 12 lies in any other number? Yes, it also lies with 4. It is in the 4th table. Let us create another factor tree then. We have started with 2 in this case. Let us take another branch starting with 3. 3 4s are 12. So, 4 is also a factor of 12. So, this tree 12 has a branch like this and has a branch like this. So, this completes the factor tree. Okay? As given in your book, you have a factor tree of 18 and you can go through it and you can fill in the blanks and find out the factor tree for 24. I hope you can very well do this now, isn't it? Okay? Students, let us solve some problems from your book. The first problem is your tiling problem. What it says? It says that there is a garden in Anu's house. In the middle of the garden, there is a path. They decided to tile the path using tiles of length 2 feet, 3 feet and 5 feet. The mason tiled the first row with 2 feet tiles, the second row with 3 feet tiles and the third row with 5 feet tiles. So, what should be the shortest path acquired by the tiling? It should be the common multiple or the smallest or the least common multiple of 2, 3, 5. So which number lies first in all the three tables? Let's check. 2 tens are 20, 3 tens are 30, 5 6 are 30. You might be thinking that, sir, there is no 30 in 2's table. But what I have told you before, there is a never ending process of multiplication of any number. It doesn't mean that we learn up to 10 and the multiplication ends at 10. No, it keeps going and going and going up to infinity. So we have 2 into 15, that is 30. Of course, we are not learning the table up to 15, we are learning each table up to 10, but there is a process of never ending multiplication which gives us 215 as 30. So 30 is the number that is the common multiple, or it is the least common multiple, or you can say smallest common multiple of 2, 3, 5. So it is the shortest path that can be built with laying the tile of 2 feet, 3 feet and 5 feet. Got it? So let's go to the other problem. Manoj has made a new house. He wants to lay tiles on the floor. The size of the room is 9 feet into 12 feet. In the market, there are 3 kinds of square tiles: 1 foot into 1 foot, 2 feet into 2 feet and 3 feet into 3 feet. Which size of tile should he purchase so that he can lay the tiles without cutting? Let's see. The dimensions are 9 into 12 feet. Okay. So this is the floor, 9 and 12 feet. Think about it. If I lay the tiles like this, if I take the tile of dimension 2 into 2, whether 9 is divisible by 2? Is it in the 2's table? No. 9 doesn't lie in the 2's table. So if I lie first tile, second tile, third tile and fourth tile, this will acquire 8 feet, 8 feet of height. Still 1 feet is remaining, so I have to cut it half to fill this 1 feet. So I cannot go for 2 into 2 feet of dimension because I have to cut it to fill the gap. What happens with 3 feet? Does 9 lie in the 3's table? Yes, 3 3's are 9. So if I lay the tiles of 3 feet, I will have 3 tiles like this, 3 feet, 3 feet, 3 feet, and it can cover 9 feet. Same as length, I have to lay 4 tiles to cover 12 feet. So I can lay the 3 into 3 feet tiles without cutting it. I can cover it by height as well as your length. Same goes with your 1 feet and 1 feet because it is also a factor of 9. 2 is not a factor of 9. So I cannot go for 2 feet. I can lay the 2 feet tile, but I have to cut it at some places. Okay. So the actual answer should be, Manoj should go for 1 into 1 feet or 3 into 3 feet tiles. Hope you understand. Let's go for the other question. The last question is all about Rani, Geeta and Nasima. I am not going to give the solution for this because I hope you have understood the concept in the previous question, and I am sure that you all can do the sum very easily without any difficulty. So this is a homework. I hope you all can solve this problem, and you will be happy enough if you can solve it by yourself, because sometimes it is good to do it by yourself, isn't it? Be my multiple and I will be your factor. what we have learned actually? We have learned about the factors and the multiples and their relationship, how they shake hand and go together. They can't live without each other. A multiple has to have some factors, and factors, they have infinite multiples. But nevertheless, all the numbers, they do not have all the factors. They have some common factors, and some factors have some common multiples. So all these things we have discussed in this chapter. Hope you understand, and see you again with a new chapter in a new class. Till then, keep smiling. Thank you.